This is my FYP project. In the beginning, I think about artificial intelligence and Internet of Things, but I couldn't decide which one to choose, so I combined them. This thing here, intelligent object searching and recognizing robot, is a combination of AI and IoT system. It's a complete IoT system with functions of finding objects, recognizing objects, and retrieving and analyzing data. It consists of three main parts: a smart card for object detection and path selection, a TensorFlow image classification model, and an Android app for centralized control and management. And the hardware components are for smart card. I use STM32 mainboard and ultrasonic sensor and infrared sensor, motors, and Bluetooth for communication. And for the image classification model, I use Raspberry Pi to hold the Android Things IoT system and Raspberry Pi camera model to capture image, and TensorFlow for the model, of course. And for Android app, I use Android Studio, mobile phone. Development tools, I develop STM32 with Q5, Android app with Android Studio, and Tensor image classification model with Python and TensorFlow library. The main system flow of this object is like the smart car will move around and detecting objects. Once it finds something, it will stop in front of the object and pause for several seconds for the Raspberry Pi to capture the image, and the image will be sent to the TensorFlow model for image classification. And the TensorFlow will recognize the image and send the result to a TTL engine. A TTL engine is a text to sound converter. It will convert the result to English. And the last step is that the Android app will get the image and sync the image to the cloud, and at the same time sync the analyze the result to the cloud, and for some further analysis like data mining to decide the performance of the classification. And the methodologies for obstacle detection, I use ultrasonic sensor to detect objects. The sensor will transmit sound wave and receive sound reflected from an object. When ultrasonic waves are incident on an object, diffuse reflection of energy takes place over a wide solid angle, which might be as high as 180 degrees. So ultrasonic is one of the best methods for one of the best simple methods for detecting objects. And for image classification, I use TensorFlow and CNN network, convolutional neural network, a multi-layer architecture consisting of alternating convolutions and nonlinearities followed by fully connected layers, leading to a softmax classification model. And the model is trained with TensorFlow CIFAR 100 dataset, which is a dataset consists of 100 classes of common daily objects. And the softmax regression applies a softmax nonlinearity to the output of the network and calculates the cross entropy between the normalized prediction and the Hall encoding of the label. For regulation, we also apply the Euro weight decay losses to all learned variables, and objective function for model is the sum of the cross entropy loss. And this is not very special, but quite powerful with an accuracy of 88.3 accuracy. And for Android app, I wrote this app and use Bluetooth communication to connect the three parts: the smart card, the image classification model, and the app, and to make them communicate with each other. And a panel on the app to control the robot body and monitor every component condition, and a display interface to retrieve the image captured and the classification result, and the function to sync the result to the cloud, And for my second half of the project, which is database, cloud computing, and data mining to deal with the large amount of results. And here is all of my FYP project.